Okay, so let me give you another problem. So you tell me what utility function do you want to see? Cobb-Douglas? Okay. Okay, suppose this is the utility function. Okay. So you have to solve the expenditure minimization problem, or basically you have to, you have to solve this problem for every possible price and satisfaction level. So you have to find the Hicksian demand function. Okay, fine. And this is your target level of satisfaction. Okay, so I mean, this is how you can do this problem. It's actually kind of straightforward. If you, we have already seen how to solve utility maximization problem for Cobb-Douglas. Okay, so the approach is kind of similar. So if you plot the constraint, I mean, for mu strictly positive, if mu is strictly positive, then the constraint set will look like this. Okay, so it will be like this region. Yes or no? Okay, and then of course you want to achieve a point in this set that that is least costly, given the prices. Okay, so of course whatever the prices are, the iso cost curves will be parallel lines. Okay, all with the slope minus px by py. Okay, so if you plot an iso cost curve, it will look like this. Okay, and then of course you can just try and achieve the lowest possible iso cost curve, given the constraint that you want to have a non-empty intersection, with this region. Okay, this constraint set. Okay, so clearly, this is the point that gives you that. Okay, and of course you can easily figure out what is the solution now. Okay, so this particular at this particular point, the slope of the iso cost curve is exactly equal to the slope of the indifference curve, which corresponds to mu level of satisfaction, which can also be thought of as the boundary of the constraint set. Okay, so all that you have to do is you just have to figure out at this point the slope of the indifference curve. So the absolute value of the slope of the indifference curve we know is marginal rate of substitution. Okay, and we know how to find that, which it's mux by muy, and we're going to get y by x. Okay, and that should be equal to the absolute value of the slope of the iso cost curve, which is px by py, right? Because this iso cost curve, this iso expenditure curve is tangential to this indifference curve. Since that's the case, so the slope of the indifference curve at this point must be equal to the slope of the iso expenditure curve or iso cost curve at this point, and therefore we are going to get this condition for optimality. Another condition that is true at this point is that this point lies on this indifference curve. So that means at this point this condition is also satisfied, xy equal to mu. So we have two equations, two unknowns. We can solve for x and y. Okay, so what are we going to get? Well, so y equals mu by x. So this is mu by x squared equals px by py. So x squared equals mu py by px. Okay, so x equals square root of this. Okay, so we can similarly write by symmetry the Hicksian demand for y, okay, as well, and we're going to get this square root of mu py by px, comma square root of mu px by py. Okay, Please note that this is for mu strictly positive. For mu 0 also this is true, because for mu equal to 0, this is a level curve. So if this is a level curve, you can achieve the minimum possible, you can achieve the target level of satisfaction by spending nothing. You can just choose 0, 0. Okay, so if you put mu equal to 0, you're going to get 0, 0. So this is also true for mu equal to 0. Is this clear? Okay.